Welcome to homework.
Alright, guys, we're doing problem 87 of chapter 2. Suppose a scientist repeats the oil drop experiment and reports the charges on the drops using an unusual and imaginary unit called the war mom. Scientist obtains this data for each of the 4 drops. If all droplets were the same size, which would fall most slowly through the apparatus? So the droplet with the most negative charge would drop the most slowly. That us. And that's going to be droplet D. Because all of these are going to be negative charges, even though the sign we're using is positive, because we're just looking at the magnitude. So drop D is going to have the largest negative charge, so it's going to fall most slowly through the apparatus. Now, from this data, what is the best choice for the charge of an electron in war moms? So, uh, so we can determine the charge of our electron by looking at the differences between two of our drops here. So let's compare A and C, which are going to have the smallest difference between charge. So we would do 3.84 minus 2.88 times 10 to the negative 8 equals 0.96 times 10 to the negative 8. Now, for C, based on your answer to part B, how many electrons are there on your answer to part B? B, and how many conversion factor between war moms and coulombs? So so this is actually pretty straightforward. To do the conversion factor. So to find how many electrons, you just do whatever your charge is divided by 0.96 times 10 negative 8. But since they're all to the same order of magnitude, we can just do it straightforward like this. So 4. Now for B, it's going to be 5 3. Now for D, it's going to be 9. Now Now, so the charge of an electron is 0.96 times 10 to the negative 8 warm-ohms, and the charge of an electron is 1.602 times 10 to the negative 19 coulombs. So these equal each other. Now we just divide both. Now we just do this. So 10 to the negative 19 coulombs per 0.96 times 10 to the negative 8 warm-ohms, and this will give us 1.7 times 10 negative 11th coulombs per warm. And if we take the reciprocal of that, that'll give us 6 times 10 to the 10th warms per coulomb.